Hello, ladies and gentlemen. We've been talking about segments, and so now it's time for the angles turn. We need to talk a little bit more about angles and get a good foundation about how angles work and what special relationships they have, what's special about them, and then we're going to build on this as the year goes along. So today we're focusing on angles. Remember that you know a little bit about angles already. You know that an angle has a vertex, they have two sides, the sides are the rays, they come together to meet at that vertex, and there's many ways we can name them, like angle BAC, angle CAB, angle A at the vertex. All of those things we already have in your notes. Remember, the vertex is sort of like the elbow of that angle, okay? That's what we want to focus on, that vertex right there when we talk about angles. You should be familiar with these types of angles. If you're not, make sure that you write them in your notes. We're going to use these quite a bit. Acute means that we're talking about angles that are less than 90 degrees. Right means we're talking about angles that are exactly 90 degrees. Obtuse means we're talking about angles that are more than 90 degrees. But notice I put in there but less than 180 because at 180 they become a straight angle or a straight line. And then you go beyond 180 in other math classes like Algebra 2, Pre-Calc, Calculus. Those become reflex angles. And you could draw an angle of 212. And you're going to get into that when you take Algebra 2 especially. So angles can also be congruent, just like segments. Now, congruent just simply means that they have the same measure. Just like segments had the same measure, they were congruent. No difference here. What's different is the way we may mark it. So this is a picture of an angle. Notice it has a little slash mark through it. Now I want a congruent angle, so if I draw another angle right beside it and I want it to be congruent, I don't have to get out a protractor and measure it to make that happen. All I need to do is draw my angle and put the same number of little slash marks through it. So because these two both have one little slash mark, that means that they are in fact meant to be congruent. Now, if I wanted to add other angles in this picture, and I want them to be congruent, guys, what I would do here is just simply draw my other angle, and I didn't have a protractor, but I meant for this angle to be congruent to this one. So notice I put two little slash marks through there because I don't want somebody to get confused and say, well, they're all the same. If they all have one little slash mark or arc, that means that they're all going to be the same. So that's the way we would mark that angles are congruent. So using those little arc marks there in our angles. Now, one other word we're going to use quite a bit in the definitions to come is adjacent. So adjacent angles are angles that are side by side. They're right next to each other. That means that they share a common ray. So here are some pictures of adjacent angles. Notice for each of these, we have a line here or a ray in the middle, and that represents the side that they share. So the pretty little colored ray here represents the side that those two angles share. And the same thing over here with my beautiful 45 in a green line here, or a ray, that means that they share that common side. That's what it means to be adjacent. They need to be side by side like this. Now these angles would not be adjacent. Notice that they don't share that common ray side. When angles are adjacent, guys, then we can use the angle addition postulate. Make sure that you write this in your notes. When we write proofs later on, this is going to be important for us. Angle addition postulate simply says that adjacent angles can be added together, just like segments. That means if I went to this angle right here, and I decided to name that A, and let's say this point right here is B, and maybe this one's C up here, and this one's D, I would write this picture in your notes, okay? It means I can measure angles and add those numbers together just like you measured segments or used measurements of segments to find the big piece of a longer segment. So with angles though, our notation is a little different. So angle addition says I can take the measure, that's what the little m stands for, of angle ABC and add to it the measure of the angle, let's go C to B to D, and that would be equal to, so if I take the measure of this angle and I add the measure of this angle to it, that would equal the whole big straight angle that we see in this picture. So the measure of angle ABD. That's what our angle addition says. Just like segments, you can add numbers that are marked on segments together to make a longer segment piece. That's the same idea with angles. Again, the little m stands for measure of angle, whatever you're given. So now, guys, we're going to take a little bit and talk about relationships. Oh, wait, no, not these relationships. These relationships. Complementary angles, supplementary angles, linear pair, and vertical angles. Sometimes you have two angles and they have a special relationship. They do something special. So they either are complementary, supplementary, maybe they're a linear pair, maybe they're what we call vertical angles. You need to make sure that these four words, oh, hey, numbering, how about that? 3, 4, that these four words are in your notes, and then next to them you can write a little definition here when we get to that on the slide. And if you want to draw a picture near them, you certainly can. Pictures help illustrate what we're trying to say. So let's first look at complementary and supplementary. So complementary angles are angles that add to make 90 degrees, while supplementary angles are angles that add to make 180 degrees. So that's all those angles really do. It's all about the numbers. Do the two numbers that are the degrees of those angles add to make 90? Then they would be considered complementary. Or if they make 180, they would be supplementary. So notice here I have two complementary angles. I have a 30 and a 60. They add together to make 90. They are complementary. Over here, maybe put some numbers in this picture, 120, 60. They add to make 180. What you don't see here in any of these definitions are that the angles have to be next to each other, because they don't. Complementary angles, you can have one angle of 45 degrees, another angle of 45 degrees way over here. They're still considered complementary. It's because the only thing that needs to happen is that their angles have to add to make 90 degrees. That their measurement just has to be at 90 when you add them together. It doesn't say anything about having to be next to each other or adjacent. The same thing applies to supplementary angles. So you can have one angle of 100 degrees, another one of 80 degrees, and you know what? It doesn't matter that they're not next to each other. They're still supplementary angles. Okay, let's take a look at the next two words, linear pair and vertical angle. So with a linear pair and vertical angles, now linear pairs have to be adjacent, so that means they have to be next to each other and making 180 degrees. Okay, so those angles have to be right next to each other, making 180. That's a little different than supplementary. They didn't have to be next to each other. Vertical angles are basically pairs of opposite angles formed when two lines intersect. So each of those pairs, there's going to be two pairs. So if we were to put this to pictures here and make sense of what those words say, this would be a linear pair. We have adjacent angles that add up to make 180 degrees, or a straight line, straight angle. Vertical angles are made when two lines intersect. So that's this picture. Two lines are intersecting. Right there in the middle is their intersection point right there. They make four angles when that happens. When they intersect, this angle right here, his opposite angle, the angle not next to him now, would be angle 3 down here. So angle 1 and angle 3 are considered vertical angles. And so would angle 2 and angle 4. So when you have this sort of letter X formation here with two lines intersecting, you really have two pairs of vertical angles in that picture. So what's so special about vertical angles? Why do we want to point them out? Why do we want to know where they're at? Because they do something very special here. So I want to take a minute here, and I'm going to escape out of this just a second, and I want to show you what happens with vertical angles on this site here. So here's a little drawing of vertical angles, and you can see the 119 right here. His vertical angle happens to be 119 right now. And so does the 61. His partner vertical angle over here is 61. Now, is that always true? Are they always the same? Well, take a look when I start moving this point around. No matter where I put it, those vertical angle pairs are always congruent. No matter what, no matter where I put that point. And I could do the same thing with C. I could really mess up the C right here. Change A, you know, put him way out here. It doesn't matter what that picture looks like or how it changes. If you have vertical angles in that picture, notice that they're always congruent. Okay, they're always the same. So that's a really important fact to know. When we talk about vertical angles, we need to make sure that we understand that vertical angles are always congruent to each other. So where you have written vertical angles and you wrote that where they meet in those opposite angles formed when two lines meet, add next to that that vertical angles are always congruent to each other. So that part in red down there, make sure that you know that. It kind of makes sense when you see it on that picture. We're going to talk more about why that is in terms of a formal proof when you come to class. But I wanted you to know that that's always the case. And then we're going to use that, of course, to help us solve for missing variables or solve for missing measurements. So what we're going to do with this knowledge that we gained today is use our knowledge to help us find x or solve for x here. And we may know the algebra for solving, but if we don't know the relationship between these two angles, we don't know exactly what to do with this. Now you should be thinking, hey, 3x plus 20, 10x minus 15, they're vertical angles. And vertical angles are always congruent. And congruent means they have the same measure. So there's something that we can set up in terms of an algebra equation to help us solve for x. Okay, that's going to be our focus when we come to class. So I want to thank you for taking good notes, ladies and gentlemen, and I will see you later.